Okay, subsequently, let's look at this. So, if it's n square minus 3 now, for part C, we see that the Tn here is n square minus 3. This kind of term is called a quadratic because n now is not to the power of 1 but to the power of 2. So it's quadratic. Okay, quadratic. Okay, so same thing. I want what is the answer for Tn? T1, term number 1, term number 2, and term number 3. Sub in the n as the number given, you will be able to find. Okay, part D. Okay, part D, now the Tn is equals to 2n the power of 3. Power of 3 is no longer quadratic. This is called a cubic. Okay, this is called a cubic. Okay, so anything first three terms, find for me. And part E. This one we don't see a square, we don't see the power of 3. So this is actually other kind of n that we see. So this one here we need to sub in. Okay, let me show you the first term, okay? Then you'll find the subsequent second and third term for this one here. So 2 bracket, okay, the n is substituted as 1 now. Okay, the n is substituted as 1 now. So I substitute 1 inside. Okay, bracket minus the power of 1. So inside I see is 1 minus 1, which is give me 0. Okay, 0 multiplied by 2 will give you 0. Okay, I will do the term number 2 for you. Okay, I want you to do term number 3 yourself. Okay, now if I substitute n as 2 now, okay, the n here will be power of 2 now. So if I take 2 minus 1, this will be equals to 1. Okay, this will end up with answer of 1. So 1 to the power of 2 is still 1. 1 times 2 give you 2. Okay, I want to see you doing number 3. Okay, let's find out the answer here. Okay, for part F, same thing. This is the other side. So we can have, if I only want to find the first 3 terms, so sub n as 1 now. So replace n as 1 plus 2, okay? So this is 1 over 3. 2, right? This is 2 plus 2. This is 2 over 4. 2 over 4 can be further reduced to become half. Okay? I want you to find term number 3. Okay? I'm going to make this part here so that I know that whether you have done your work or not. Okay. The above shows the importance of or the usefulness of the general term Tn or n term. Okay, remember this. And also recall the use of the general term to show or prove if a given value is a term or not a term in a particular sequence. Okay, this just to say that in the previous number pattern, right? Let's say I want to show whether 2, 4, 3 is in this sequence. Remember that I must write out 2. If I know the n term, let's say I know the n term as 2n plus 3. If I want to find out this 2, 4, 3 is it in this term, or show that is it in this term, I must equate 2, 4, 3, okay, equals to 2n plus 3. Okay, something like that. Okay, please refer back to your previous number pattern to see. Okay, question part 2, to determine explain if a given term or not in a particular sequence or number pattern. Same thing like what I said, just need to equate to the n term of the sequence, then solve for n. Okay, so what is telling you to do is for this kind of question, Okay, for this kind of question, then just use that number that is given to you, then find out if the Tn is given to you. Let's say is 2n plus 3. Okay, this is example. To show whether this term or not is a particular term in a pattern, or to show that is it in this sequence, you just need to equate. Okay, equate, then solve. Okay, n equals to 1. Okay, I hope that you remember this. And when you know that n is a whole number, okay, n is a whole number, it is in this sequence. If n is not an integer, it is not going to be in this sequence. Okay, that's all.